Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This is the first video in a planned playlist on statistical tests. It is called T-Tests Part 1 of 2 Overview. As you can see, the others in this playlist that I plan to do, we have a second on t-tests, 3 videos on chi-square tests, and 1 on non-parametric tests. The F-test is already covered in the video F, the test statistic and its distributions, which is in the playlist on distributions. If you're not familiar with the test statistic T, you may want to view the video T, the test statistic and its distributions. There is also a video on Z as a test statistic. As usual, in the book and in these videos, we'll start by going quickly through a list of keys to understanding, or KTUs. This will give you the overall picture of the concept on a single page. And then we'll go into detailed explanations of each of the keys. For this video, there are 5 KTUs. The first key to understanding tells us that the 3 types of t-tests are differentiated by the types of means that they compare. KTU number 2 says assumptions for the data are normality and, for the 2-sample t-test, equal variance. We will be looking at 3 different types of t-tests. The third key to understanding tells us about the first of these. It says the 1-sample t-test compares a calculated sample mean to a mean which we specify. Key to understanding number 4 says the 2-sample t-test is also known as the independent samples t-test. It compares the means of 2 samples, one from each of 2 different populations or processes. And the final KTU states the paired t-test, also known as the dependent samples t-test, compares the differences between pairs of measurements taken from the same test subjects. The 2 measurements in a pair are taken at different times or under different conditions. And here on one page are all 5 keys to understanding the concept of t-tests, part 1. You may wish to pause the video at this point and read them all together. Okay, now let's take a closer look at each key to understanding. First, KTU number 1 says the 3 types of t-tests are differentiated by the types of means that they compare. The comparing in the t-tests basically calculates whether there is a statistically significant difference between the 2 means. This table gives us the specific for each of the 3 types of t-test. First, the 1-sample t-test compares the sample mean to a specified mean. The sample mean is calculated from a sample of data which we take from one population or one process. There is only this one sample in the 1-sample t-test. We'll explain later what a specified mean is. In a 2-sample t-test, we collect 1 sample from each of 2 populations or processes. Then we calculate the 2 means and compare them. More on this under KTU number 4. Finally, the paired t-test compares the mean of the differences in pairs of measurements to a mean of 0. We'll explain this further under KTU number 5. Tests in statistics often have restrictions on the kinds of data that can use the test. These are called assumptions. All t distributions are bell-shaped and symmetrical. As the sample size increases, t-distributions get closer and closer to the normal distribution. So, if we are going to use the values and probabilities of a t-distribution, the data must be at least roughly normal. Now, how do we know if the data are normal enough? Well, many software packages do a normality test, such as the Anderson-Darling, as part of the t-test. If the Anderson-Darling p-value is greater than the chosen significance level alpha, then the data are normally enough. To be certain, it's good to take a look at a normal probability plot to make sure the plot points roughly track the straight line relatively closely. The two-sample t-test has an additional requirement. The variance of the two samples must be roughly equal. If the data are roughly normal, the f-test can be used to test for equal variances. If the variances are not roughly equal, the non-parametric Welch's t-test can be used. Moving on to KTU number 3. The one-sample t-test compares a calculated sample mean to a mean which we specify. The sample mean is calculated from the one sample of data which we have collected. And the mean we specify can be, for example, a goal, or it could be a mean calculated outside of our test, for example, a national average or a competitor's mean. It could be an estimated or hypothesized mean, or it could be a historical mean. Note that for all these specified means, we do not collect a sample and calculate a mean. We take a mean that has already been calculated or specified by someone else or by us. The one sample t-test will tell us whether there is a statistically significant difference between our sample mean and the comparison mean. In the two-sample t-test, one sample of data is taken from each of two different populations or processes, giving us two samples. The means of the two samples are compared with each other in the t-test to determine if there is a statistically significant difference. This test is sometimes called the independent samples t-test. Samples are said to be independent if they come from unrelated populations or processes, and the samples have no effect on each other. The table shows a sample of size n equals 6 on the left. This was taken from a population of workers who have not undergone training. On the right, we have a sample of size n equals 5, taken from a different populations, workers who had been trained. We can use a two-sample t-test to compare these two samples and attempt to conclude whether or not trained workers do better than untrained workers. You may have some suspicions that this may not be the best way to go about determining the effectiveness of the training. After all, there could be other factors at work here, like a worker's experience level or skill level. So comparing two sets of workers may not be the best approach. How about we take one set of workers and measure them before and after training? On the left side, we have the table from the previous slide illustrating the two-sample t-test. On the right is a table showing the results of a paired t-test. As KTU number 5 says, the paired, aka dependent, samples t-test compares the differences between pairs of measurements taken from the same test subjects at different times or under different conditions. On the right, we have only one population. For each worker, we compare the results before training and after training. This eliminates many of the possible additional factors that could come into play if we had two populations, like with the two-sample t-test. Okay, that concludes our overview of t-tests. Coming next will be the part 2 video, which goes through the calculations and analysis involved with the t-tests. See the website for the latest status. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatoz.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromatozcom/blog. I've got some things there that hopefully you will find interesting, like a statistics tip of the week series, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page Statistics from A to Z and on Twitter at Stats A to Z.